Very excited to show you some of the details we've learned by working with multinationals globally on hybrid network and SD WAN connectivity monitoring, troubleshooting, and optimization. So we will look at the trends of the market, the underlying principles of SD WAN networking, and then also look at some live traffic and how you can effectively monitor and troubleshoot issues with these networks. SD WAN is starting to really take off as a important trend. Now we see 2/3 of enterprises using SD WAN for their critical business traffic. The SD WAN is largely replacing the MPLS fixed private connectivity. This is driven by a few factors. One is that there are more employees working from home, and SD WAN is easier to deploy across larger areas and closer to the end user. And that's being coupled by the deployment of cloud access security brokers that are also being deployed generally to secure the larger perimeter of highly distributed sites and individuals. The other trend that we're seeing is that a lot of enterprise applications are now starting to interconnect with each other. There's a lot of east-west traffic between SaaS, cloud, and corporate sites. These are really dramatically shifted into cloud or SaaS-based applications, largely for cost and resilience reasons, but also so that they can provide this interconnection between their systems. All this means that networks are becoming even more important than they were before, but they are also getting quite a bit more complex. One thing that we've seen as people move to SaaS and cloud-based applications is that those applications like Salesforce or SAP or Office 365 is more and more defined by the network experience itself. So when you look at this chart across all the different regions, that the network is responsible for over 80% of latency to applications. This is being accelerated because of the amount of traffic going to SaaS in the cloud, of course. But what's concerning when you look at IT organizations and network operations, that often the tools that they have available to them don't really effectively resolve this new kind of network dynamic. There's a lot of other connectivity options being combined together into these connectivity fabrics that we see today across on-premise, remote workers connecting in through VPNs, remote branches or manufacturing sites that need to connect to each other, but also to SaaS and cloud, as well as private data centers. And you have work from home users that are using their own internet service provider to connect directly to the cloud and the SaaS applications that they're using. And to that extent, this is where we start to see the secure service edge or CASB type solutions being used to provide some form of proxy that secures their access to these cloud-based platforms. So there's essentially 7 different kinds of connectivity that need to be monitored in a hybrid connectivity matrix. There's the cloud to cloud, so when clouds are interacting with each other or there's transfer between them. Cloud to SaaS applications, which is quite common, where you maybe have a Redshift database on AWS that you want to connect with something like Salesforce. We have the cloud to SaaS to data center connectivity. Then there's the different forms of on-premise, so to the different SaaS, cloud, and data center targets, as well as the remote VPN users, the branch connectivity that connects not only to centralized resources, but also to each other. And then the work from home user, as we mentioned a few minutes ago. So each of these different connections has an impact on business performance, has an impact on how systems and applications are accessed, and most of all, the digital experience of the customer or the employee. These are critical factors today, especially in the area of human resources and retention, where we've seen that more than 1/3 of users will actually change their companies and jobs to get a better IT experience when they feel that they can't be productive in their current environment. There is a visibility gap, as I mentioned, with these particular services. Let's take a look at what the difference is. We're seeing a very wide range of distribution of applications now and hosting locations compared to having all of the applications originally hosted in a data center. So this diversity of applications makes it much more difficult to monitor using traffic analysis-based techniques. Also, not only is there many different application destinations, but any one SaaS or cloud hosting provider will have multiple locations as well, or different host names behind them that can be localized in different regions. So you have load balancing that will maybe redirect one person from one cloud zone to another one as required to maintain performance. From a network perspective, there's strong encryption now, TLS 1.3, which is securing the traffic between SaaS in the cloud and web locations and the end users, which makes it very difficult to analyze network traffic to determine the breakdown of applications, their destination, but also to be able to aggregate all of those different collection points into one point of view is extremely difficult. You also have people over here that say work from home where there is no real ability to monitor their traffic easily. In an SD WAN environment, as you see here connecting different sites and locations, there's also the dynamics of the network underlays that are taken to transit between these different SD WAN locations. So typically SD WAN appliances will show you the overlay performance between sites, but will neglect to be able to analyze what's happening on the underlay level where many public networks are used to transit between sites. We'll take a look at this with live traffic at just after this quick presentation. And finally, there's geo-based location and redirection, which is a problem for a lot of users. If the ISP doesn't have a good understanding of exactly where your location is, or if the DNS records are not correct, you might be redirected to a completely different location far from your geography to access an application. And this is also occurs with CASB as well as DNS solutions. So in the end, we need a different way to look at how these different pieces interconnect, especially as we start to migrate from the more traditional network into this fully hybrid model. Take a look at SD-WAN migration as an example of this process. So there's different best practices that are necessary to ensure that performance remains stable and that the users have easy access, reliable connectivity, and a low loss and high performance in the application transactions. And the first need is to be able to really benchmark what the existing network looks like, what the users are currently experiencing from application standpoint, and what the connectivity is that's delivering this today. When you move to a new deployment and you start to migrate people onto an SD-WAN or a hybrid network type environment, you're going to want to compare how the performance is on each of these routes before and after the migration. So what this means is you have to have a benchmark before, and as you bring on the different sites, you have to be able to quickly determine if the behavior or the performance between these locations is dramatically impacted or improved meeting your benchmarks or not. And this allows you to quickly adjust and configure your SD-WAN appliances to optimize the routing between these locations. In addition, you might have some problems with the local service providers or internet service providers that have different peering relationships and BGP routing policies. Those can also be optimized by having clear evidence from network analysis that will tell you exactly where the bottlenecks are in these new networks. So here's the 7 top sources of network performance degradation. As we just mentioned, suboptimal DNS resolution is one of the big ones where you have a dramatically increased latency due to an inefficient network path. The same is true if your internet service provider or the ones that are being provided for SD-WAN underlays have BGP routing policies that are not optimized for your business locations or applications, or if they're routing based on lowest cost instead of best performance. Third is the same kind of delays that can occur from a CASB security perimeter, and you'll see a video we just recently posted on Kadiska.com and YouTube about how CASB needs to be benchmarked for your applications, and also you can review the recording from earlier this week at the NetCore Cloud Week on CASB performance. But there are multiple sources of delays in these complex security deployments that need to be factored in when you're troubleshooting overall hybrid network performance. In addition, there is when underlay path changes, which we can take a look at in a minute, application and content delivery network load balancing, workers' own networks at home, and then if you enter into a cloud network at any point between yourself and the application or the cloud, you'll see very quickly that that's an extremely complex environment that can introduce a lot of loss and latency. So many different variables here to monitor. And the best practice in this situation would be to ensure that you have a unified view, integrated view of all of these issues so that you can quickly decide which IT team or which member of your IT organization should be taking action to resolve the problems. So the necessary kind of visibility that you would need first starts with having the ability to see along the entire route or the entire path for any dynamic network. So you can see where along the routed path there is a degradation that can be mitigated. This also includes the ability to look at both SD-WANs on the overlay, so how the sites are connected, but then the underlying networks that allow them to transit the traffic. The ability to look at each hop along the path to know where latency and loss is most occurring, so you can pinpoint the operator or the location that's causing the problems. And then be able to look back in time at the path performance by region or site or user so that you can trend and predict and proactively look for issues that you could mitigate. And finally, it's actually quite useful to be able to measure network performance in the context of the end user's application performance and their digital experience. And this is because if you have the context of the user, often you can find that when they call the help desk and complain about poor performance, that many times it's not the network. And if it's not the network, then you don't want your IT teams spending time analyzing networks that are actually not at fault. So understanding where the problems are when there's so many different kinds of sources is actually quite important. So I'm going to show you a demo, but first I will give you an example of how Kadiska monitors this kind of complex network environment. Primarily, the enterprises will deploy what we call an enterprise test station, which is for network path analysis and end-to-end performance analysis to test between sites proactively using synthetic testing. And for locations where there's users at home, for example, we can deploy or employ or manage stations that Kadiska hosts around the world, and they'll be able to take the ones that are closest to the locations of the users and replicate the kind of network path performance that they receive, even if they're connecting from a remote personal ISP versus on-site at a corporate location. And finally, to really understand the digital experience and how it correlates with network performance, we have what we call the user watcher, which is a simple browser extension that runs on the user's device that allows you to correlate how their page load performance is, transactions to key SaaS applications, and the network device and server response time, so you understand when the network is actually needs to be analyzed in depth. So with those different attributes in mind, there's quite a few different benefits that you have with this new level of visibility. And I think the most important one to highlight here is really being able to hold your connectivity providers accountable. Because in this new environment, there's many different vendors involved. There's internet service providers, there's traditional telecom service providers, there's SaaS vendors, there's cloud providers, and there's CASB providers. So we're really talking about a world now where there's much less control directly in the hands of the IT organizations, but the ability to provide evidence and show them directly the problem is theirs creates a much more productive conversation between yourself and those vendors, and it leads to a much faster resolution time. It also helps you ensure that the SLAs you have with those vendors are being respected and enforced. So what I wanted to do is show you 3 quick examples of what it looks like to see hybrid networks from the inside. So what I'll do here for a second is I'm going to stop sharing this and I'll bring you to view of the Kadiska platform. And we're going to take a look at a couple of different elements in the platform. The first is we're going to look at the user experience side just to see what it looks like to understand quickly if a problem that is being reported is actually coming from the network, the server, or the client side. So if I take our website here at kadiska.com as an example, I'll zoom this in to make it a little easier. If I click on that, I can directly see the application performance for different users. And you can see rapidly the number of people that are connected, how long that they're using it for, and then the latency, average latency to reach our server, and how long it takes to load the full page in, and the loading progression over time. So how did it look like yesterday or earlier today? And so you can see any variation in the loading time, as well as whether there's any errors or not. So very easy to see what's going on with the server, with the application, how it's perceived in different regions. But you can also see by the service provider for remote users which ones are having different kinds of problems. So we can easily hover over this, for example, and show that in this case, the network side, which is represented by the yellow, is actually very fast, but the problem is split over data transfer time and server response time. Here we have a problem with the user's browser where it's waiting to process, let's say something like the CSS to make sure that the page can be rendered properly. And then you have other users where, depending on how they connect, they have sometimes a very long network times. 97 milliseconds to connect plus a network setup time, 75 milliseconds, for example, is too long to have a productive Teams call, for example. So we can show you quickly which networks are having the biggest problem, whether they're CASBs or SD WANs from any one of these type of providers, for example. And then you can also see down to the user level and see who's being impacted for a specific kind of application. So if I took that as an example, it's good to see which users are being impacted and what's their reasoning for that. So this user, for example, has a very long network problem time. If we filter on them, we can also learn a little bit more about how they're using the platform and where the problems have come from. So So this is really the processing times. This is their provider, and we see that they're actually located in the United States. What this tells us is we can then go and do a detailed analysis of what the network performance looks like from those locations to understand if the hybrid network is performing properly or not. So I'll show you an example of something that represents more of an SD WAN type environment. So what we're seeing here now is all the locations around the world where we're testing with Kadiska's managed test stations, so you can see how many we have globally. But if I wanted to show you something that represents what SD-WAN configuration network might look like, I'll take an example of an SD-WAN that will connect together, let's say, 3 different cloud sites. And we'll take a look at that. And so you have one here in California, one in Paris, one in São Paulo in Brazil, and we want to see how these 3 different sites are connected together. So by selecting the 3 sites together, we'll be able to actually analyze how well they perform. And you can see there's already some loss on each one of them and a fairly long latency, which would be expected from the distance that they have to each other. And these are the kind of basic metrics that you get from an SD-WAN integrated native monitoring capability directly from the SD-WAN solution provider. It's not quite enough to know what's going wrong or why there's loss or latency, but this is the kind of information that's provided with those solutions. If we wanted to go into a deeper look and see what's happening underneath the scenes, we can do a path performance analysis, and I'll shorten this down to, let's say, 24 hours. And what we're doing here now is we're testing from each of those locations to all the other locations. So from São Paulo to Paris, from Paris to California. And the reason why this took a few seconds to come up is because it's a very complex network underneath. What we're seeing here is all the different service providers, but at some point, the traffic in almost all these cases transits into the Amazon cloud network, which is what this crazy complex network is in the middle. So what I'll do to simplify this view, I'm going to reduce it down to the different autonomous systems and providers. You can see more clearly, this is all of those down to something simple. And now we can click on, let's say, California and see how California is connecting to the other 2 SD-WAN sites, or how Paris is connecting to the other 2 sites, and so on. So you can look at it from both directions and see what the performance is. And we could also look and see where the delay or the loss is in any given combination. So if I pick Paris to, let's say, São Paulo, we can see that the largest delay occurs here, which will be when we're moving from one service provider to the other side of the Atlantic. So very useful tools to be able to find out very quickly which routes are causing the problem, and if you have a loss between which operators, so that you can resolve that. So this is the example of sites connecting to each other, but I want to show you what it looks like to be able to do an underlay performance analysis from simply one site to a particular application. So if in this case, let's take a look at clearing these out, and I'm going to look only at one application. We'll pick, say, Dropbox, as a location that's still popular with quite a few enterprises, and then we'll see how just the Dropbox, where the performance is and how it looks from different locations around the world. So if I want to focus in on a particular SD-WAN site, we're going to take a look at all the different stations there. And I think what I'll do is look at one site that looks like it's having trouble in Spain. So we'll take Madrid. We have 2 SD-WAN underlays running here. So if I wanted to see how that SD-WAN link looked like from Madrid to Dropbox, we could do a performance analysis of that. And what you'll see here is that if you can imagine, this is actually one SD-WAN site in Madrid, and they're using 2 different ISP underlays to get from there to Dropbox. If you look at that, you can see one underlay is going through this service provider, Ascense, then passing to another one, the Spanish Internet Exchange, and then it's actually crossing over to Ireland, and then it's getting to Dropbox, which is hosted in Spain. So a bit of an inefficient route to go to Ireland and back to Spain when they were already in Spain. But the other underlay is actually even more significantly slow because it's passing through many different hops, through the Netherlands or through level 3 in Spain, then back. And so you can see in the end, it all converges back to the same location. If you were configuring your SD-WAN, you would pick the one that has the lowest latency. So in this case, the better performing route looks like the red one most of the time. So this is this route here, but when once in a while there's a big spike in the red one, and then it would be actually better to pass to the first internet service provider during that time. So this would help you optimize the routing tables and the BGP policies that would impact your SD-WAN. And that this definitely helps understand also which service providers you should select to use in your SD-WAN as an underlay and whether they're performing properly or not. You can see things like this loss over here for that one particular provider was probably something that created quite a few problems and disruptions with, say, Microsoft Teams call or Zoom calls. One last thing I want to show you before we wrap up the webinar is that this is a simple scenario of what it looks like for an SD-WAN to connect through the underlays to a particular application. But it's actually not typical that this is the way it works. Normally, if I pick a different application, so in this case, I'll switch this to HubSpot, which is the CRM that we're using. We'll see a more typical behavior, which makes life even more complicated and important to be able to measure properly. I'll pick a couple of stations here. So what we know at HubSpot is more than just one server. There's a number of different host names that actually are required to reach to get the different services. And this is a more typical example of what you would see from the different underlays, is that actually each underlay has to reach different hosts, the CDN, the APIs, and the application itself to make sure that the digital experience in the application performs properly. So you can see with this that it's actually far more complex than just different sites reaching one target, because if you enter into one ISP, you might actually be directed to one HubSpot API server, but if you come back later, you might be directed to a completely different API server. So this one's in Canada, for example, and this one here is also in Canada, so it's going through the Cloudflare network. If you're looking for the other ISP, sometimes they're connecting to completely different targets. And this is what can create extreme difficulty in terms of troubleshooting issues that are happening across an SD-WAN. So this kind of tool that allows you to see the underlay quickly and have those conversations with your service provider can really truly accelerate how your teams work together and help you realize the benefits of SD-WAN in terms of cost and performance much more quickly. So that's the demo I wanted to show you in terms of SD-WAN monitoring. You can also hybrid network monitoring, just to show you how quickly you can find the problems that are impacting your users based on their digital experience that you can measure, or just based on network path and network performance.